This is part 2 of the lecture on Chapter 14, Java FX Basics, and with where the author discussed the differences between Java FX. So let's move on to the next slide. Now this is just
Alt was
taken from
was introduced when Java was first introduced
commercially.
You create
your first Java FX application.
and Alt stands for Abstract Windows
Toolkit. So here's a different
time
where
import, and we're going to talk about
what these things
or at least computer
are.
platforms,
The
really independent.
The window that you
Meaning
want to display.
it was
needs
very
to extend
difficult to
an
have
application
software
that was loaded,
or at least the
on
object needs
a
to extend an
PC
application
that could actually
run
and then
off
that
of
class, whatever that class is.
Back then, we're talking
you're going to
about this is
have
before
you're going to overwrite the
computers
start
became
method,
known
pass
as
it a
Macs.
stage, primary
This is when-
stage.
Yeah, Macintosh.
And inside this
also known as
code,
Apple.
or inside this method, I have code.
So we're talking
where
about
I'm creating a
early
button.
90s.
Then I create a scene. We'll talk about what a
and
scene
then
is
you also had
in the
the
next few
Unix, so
slides.
Linux,
I give the
platform.
window a stand. In most cases,
stage is the
window.
So
So
the
stage
software
object is a
was
window.
incompatible.
So I give the primary
So you
stage
can only
a
use
title,
software on a
and then I have to add a
specific,
scene to
platform.
the stage.
Again,
Because
we'll
of
discuss
that,
what the scene
James
is later.
Gosling,
And then I
have
person
to show the
developed,
stage. This line of code, primary stage I
Java.
show, is what displays
came
the
up with
window.
this
You don't do
abstract Windows
this,
toolkit,
and it was
you
just
won't see anything.
Now
It
the
just
code
took
I have down
the
here is commented
graphics
out.
that was specific
You
to the
technically
machine
don't
that was
need
running
this.
on.
In his case, if you have an IDE
Java
with
was
limited
when he designed
support,
Java,
then
if
you
you guys
do.
recall,
When you do a
designed
My
it
Java
primarily
FX
so that it
extends,
can
or I'm sorry, when you do a class
cross
that
that gap
extends
between
the
platforms.
application,
The first
and that
software,
you override your
devices,
start method.
software
When you
languages,
run
can
it,
actually
it should call
be
this
developed, where you
automatically.
can develop software.
To do that in
on
JGrass, you have to
Macintosh
do the
machine.
build,
and then you can also
and
port
then
that
select Run
software
as
on a
Application,
Windows machine.
and that will
And then
launch
port that
this.
software on
If you
a
just
Linux
want to
machine,
run it the
everything will
normal
work.
way,
So the way
then
he
you
did it,
will
the way he
need the
designed
public
it
static
was,
void main
it
uncommented
would
out
only
with
grab
this line of
the
code application
graphics
with the big A
from
dot launch, and
the
you're passing in the
specific machine
R.
it was using.
So this
So of
method
course
here
is
under
a
the
simple
application
GUI library
class
it was
calls
very buggy,
the start method.
things of that nature.
Now, Swing was a more comprehensive GUI library.
Let's talk
Now,
about
this was much more platform independent.
the whole
reason why.
structure.
Swing had
being,
its own
something to display,
or at least a lot more
Java
graphics
FX.
within its own GUI library.
So
So
it
a
wasn't
stage is a
gonna
window, and I
use
think the developers who came up with Java
graphics
FX,
that
they
were
must have a background in
specific to
or interest in
platform.
performing arts.
Because
Now,
I see this,
having
the
said that, now
stage
Swing
scene
came out
metaphor,
probably with late
being used
'90s.
where the stage
and it
is
was
your
very useful
your,
for
I guess
the
your first
viewing
decade of,
area, and then the
this
scene is
century. What gets
But there
what
were
gets put
some
onto
issues with
the
Swing.
what gets
For
presented to the
example, you
audience.
really
You can have
couldn't do
multiple
3D. I
scenes,
mean, they had a 3D
things of that
library.
nature.
So
Swing.
let's talk through this.
I
Your
played
stages
around
are
with
with
it.
couldn't
When we
compare that to
compare
Swing.
the
Swing
animation
that was
frame
was
or
hitting
JFrame.
this, depending upon what you're doing.
Sometimes it would
But the
work
stage
well.
is the
Other times
main
it was
window,
really buggy
and everything
and
gets
really
put inside
choppy.
the stage. And you
I don't
use that
recall
title
if there
method
was any
to display the title
capabilities
video
on the window.
And at that time,
Now, your
mobile
scene is an
technologies
object
wasn't
that
what it is
attaches
now.
to the
So
stage.
there wasn't
via
the
the
set
scene
scene
available
method.
for mobile technologies.
So now you came up
we
with
can
create
Java
panes.
FX,
You don't have to create
and
panes.
Java
In the last
FX is
example, we didn't create a pane. We added something
much
directly to the scene,
better
and we put the scene to the stage.
enhancant
But
to
in that
Swing.
case, if you
In
in
fact,
fact were to
it's
run
so
that
much
code and
better
display, you have
that
a
Swing
one
is no
button
longer
that
being
takes up the
supported.
entire window. That's not really
So
useful.
you know, when we look at the
We're
difference
going to
between
develop
Alt Swing
really,
and Java
really nice
FX.
looking. When Swing was
UIs, and
introduced,
do that,
Alt
we're
will
gonna still be-
have to
would still
add
be
this
used.
other component called a pane.
Now that Java
and a
FX
pane
has
is
been
a
introduced,
container class
they're no longer
that will hold all visual
supporting
components.
previous to,
With a pane, you can
graphics
specify location
library.
and size of each component.
Java FX has
as well as
functionality for
for
2D,
2D, specify
3D,
location, animation,
location
video,
of the
and
components
mobile, and how big you want them to
specifically
be.
with mobile, you can do
And
a
then
lot
in
of
most cases,
swipe,
we will be using a layout
interactions,
pane
which
class,
we'll learn about
and
interactions
then
in
attach that
chapter
to the scene, and we'll
15.
talk about
But
that
Java FX
later.
is definitely the
With
graphics
with the
library
pane, you
that,
can create nodes.
Java
These nodes
plans
are
to
visual
use and
components.
probably
A node
plans
can
to
be
use for a
anything
very
from a
long time.
button
So
to a
it's
radio
really
button, a
important that you learn Java FX.
checkbox
It's new.
button.
I think
A node can
it
also
was
be a label.
introduced
Node
probably
can
in the
be
late
text.
I think
Node
2008,
can
maybe
be,
2009.
almost anything you want to be visually displayed.
And I think at
to the
Kennesaw
user.
State, we
And
have
the best practice you guys can see down here is
discussed
we're going
Java
to
FX.
create a
in most of our
node,
classes. I think in
or
CS
create nodes,
2,
attach nodes to
this
the
will be our
pane,
second
attach-
semester
or
teaching Java
panes,
FX. So you
attach
guys
the
are,
pane or panes to the
in
scene, and then we
you guys
attach
are
the
ahead of
scene
the
to the
curve when it
stage.
comes to
That would be the
to
best
learning
practice to go
Java
about it.
FX and
Now, and to understand how your a scene works and how to just lay things out in the most basic case, we have to talk about absolute positioning. Absolute positioning. You guys remember? I think it was chapter 12 where we talked about absolute pathing, where the location of the file was absolute to where it is, where it sat on the computer. The same thing works here in absolute positioning, where I can tell a pane or node to display itself that is specific to the location in the window area, okay? And we use this Java coordinate system you see on the left, where if this is my window, we have 0, 0 will be in the upper left-hand corner, and as you go horizontally, you increase in X. So this is your X-axis. And then as you go down, you increase in Y-axis. So let's compare that to the conventional coordinate system, where, and you guys have all seen this back in your basic math classes, where X to the right is increases, Y going up increases. In this case, X to the right still increases, but Y going down increases. And 0, 0 is the left-hand corner. And as you can see here, if I go 50 over, 10 down, I'm at 50, 10. And if I go 10 over, 50 down, I'm at 10, 50. So the X always goes first in front of the Y. It's pretty straightforward on how to do this. Now here's an example of how to use absolute positioning. Now again, we're not doing a layout class. We'll talk about a layout class shortly. And all I have here, and this is the example from the book, we're doing a show circle, and it extends the application. And we're just going to put a circle dead smack in the middle of the window. We have our scene, you guys can see here, at 200, 200. So we're going to set a circle, and the circle is going to be positioned at 100, 100. And we set the radius to 50. And if we displayed it, you would get a circle that's in the middle of the screen. And that's pretty much it. Now, there's two things to note. The first thing, I want you to see how I am breaking up my code. I have multiple methods that do one specific thing. At least I'm trying to get to do one specific thing. And the purpose of this is, and I may have explained this before, or at least try to introduce you guys to the concept of separating your code. And in object-oriented programming, we discussed this in chapter 10 and even in 11, where we discussed how to make sure we modularize our code and separate it so that there's levels of abstraction. So where we have methods doing, we have one method doing something, another method doing something different, and we put all the pieces together, we have our full picture. It becomes even more important when we do UIs, because we're going to be developing UIs with so many different components and so much functionality that you really want to make sure you practice separating your code. Otherwise, you can have one method or two methods that are doing way too much more than it actually should. When I was in industry, I think most organizations I worked in, if not all the organizations I worked in, had a policy where a method could not be written, or one method couldn't have more than, I think, 25 lines of code. I really encourage you guys to start thinking about how to do that. Yes, it is very easy to just write everything in your start method, but it's really sloppy and it's poor programming. It's very poor programming to do something like that. You really want to make sure you understand how to separate your code. So as you guys can see, we go in our start. I have this initialize method, and I'm initializing my nodes as well as my pane, my scene, and I set my primary stage, the title, and I set the scene, and then I initialize my circle from within the init method. So I take care of all the circle stuff here. I initialize my pane. I take care of that inside initialize pane, and I initialize my scene here. So these things are all doing something different. So that's the first thing you guys want to make sure you're trying to get an understanding of how to do. And of course, it's really difficult to do unless you design your code properly. And with UIs, it gives us the opportunity to design our code. So hopefully you're doing that. And then the second thing I want you guys to understand, if you were to run this code, you would not be able. We would get our UI, but if we decided to make our window bigger or smaller, the circle won't move. So I can make my window bigger, and then the circle would no longer be, depending on how big I make the window, the circle will no longer be in the middle of the window. And if I make my circle or my window too small, I can actually hide the circle, so the circle is no longer visible. So this is not really a proper way of doing it. Absolute positioning works in certain situations, but there are some limitations with it. Because the nodes are specific to the size of the window that's been set in code. And if you resize your window, then the nodes remain in their original position, which now makes your window may not look the way you want. So there are some options to resolve this limitation. You can disable the ability for the user to resize this window. You can just set that as a false. You'll typically see this for pop-ups, for things that or login screens, things that need to be small, that probably need to be set to a certain size, and you do not want the user to resize it. Another way of doing it is to do property binding, which we'll discuss later, and then we will discuss how to use relative positioning layouts to actually accomplish this with a little more effectiveness than property binding. But let's talk about property binding first. Property binding, and this is a key definition to know, is where you set a target object to a source object, and then where the change in the source will automatically be reflected in the target object. So if I change something here, which is my source, then it's going to change whatever this target object, because these guys are bound. So if I change the size here, it changes the size here automatically. I can't show this in PowerPoint, or at least I don't know how to do this in this version of PowerPoint. I know in the older version, I think it was the easy way of doing it. But this is from the book, The Show Circle Centered. I will also post this on my webpage. But as you can see, if you decide to implement this code and run it, you will get the circle, the stage, or the window with the circle in the middle. And if you resized the window, then the circle will continue to stay in the middle. So that does accomplish it to a certain extent. However, you will still see some issues. If you make the window really big, then it no longer becomes a circle. And if you make the window too small, you can still hide the circle. So there are still some issues with property binding. It's useful, but there are still limitations to it. So a better now another thing that's difficult with property binding, if we were to do it this way and we had a full comprehensive UI where we had multiple buttons, we had text and labels, things of that nature, we had a lot of visual components that we're displaying, and we want to do property binding for all those things, then it's going to require several mathematical functions. And that may be something that I think I'm finding that a lot of computer science majors, they chose computer science because they want to get away from math. So I don't know if this is something you would like to do. And then you will still, because even if you have these mathematical functions in play, the window can get so big that certain objects can obscure other objects or overlap other objects. So you may need to still set minimum and maximum values for your windows, which you probably won't know how to do without trial and error. So there are some limitations here. And the alternative is just let Java handle the resizing via layout panes. And we're going to discuss that in great detail coming up now. But before I do that, let's talk about what relative positioning is. So as you guys can see, I have let's say this green area is my window, and I want the button to be displayed in the center of the window. I can use relative positioning to say, I always want this button in the middle of the window. If the window is this size, keep the button here. And if the window is this size, the button stays here. And it's a really easy thing to do with layout panes. And in fact, I use layout panes every time I code. I must have developed over 100 UIs in my lifetime, and I've always used layout panes. So this is something I really encourage you to understand. We're on layout panes. So from part one, we talked about what JavaFX is, compared it to Swing and its predecessor, Swing and Alt. And we talked about how to use absolute positioning and talked about some limitations with absolute positioning. Then we talked about how property bindings can be used to resolve some of those limitations. But even with those limitations, or even with property binding, there's still some limitations. And this is where layout panes come into play, where we have a class or a set of classes. It's a library where it handles relative positioning of layout or of nodes, visual components on your UI. And these layout panes, they automatically have constraints to define how to use those relative positioning capabilities to lay out those nodes. And again, they resolve the issues provided through the absolute positioning from just using your basic pane class. Now you see at the bottom of the slide we have a few layout pane classes, and we'll talk about each one of these guys shortly. But they are stack pane, flow pane, grid pane, border pane, HBox, and a VBox. HBox stands for horizontal box, and VBox stands for vertical box. Now here is a Java code where I am creating all the panes. So as you guys can see, I'm going to have multiple stages. Each stage will include one pane. First one will be a flow pane, stack pane, grid pane, border pane, HBox, and VBox. And I'm just going to add 3 buttons on each. And we'll talk about the differences in the next slide. So here we are. So flow pane, as you can see, is this first one on the left. Now, flow pane says you're going to, for every visual component you add, you're going to just put it from left to right, top to bottom. So similar to reading or writing text in a document where you start from the upper left-hand corner, you work your way to the right. When you get to the far right-hand side, or far right-hand edge, you go down a line, and then you start the process all over again. So in this case, I have 3 buttons laid out from left to right. And if I had, let's say, I think 6 buttons, I guess the 5th and the 6th button, definitely the 6th button would be down here. So that's what a flow pane is. Now, with each pane, we can do some insets, which is another class, and that can put some separation between our visual components. But I'm just giving you guys just a really high-level, basic overview of what these panes are. The next one is a stack pane. As you can see, we only have 1 button. I added 3 buttons, but as you can see, you only see 1. The way a stack pane works, it will, and it's called a stack pane because it will stack each of your visual components on top of each other. So when we're doing buttons like this, it's not all that useful because it's going to stack all the buttons on top of each other. The reason why you see the 3rd button is because that was the one that got added last. So it shows the one that gets added last. A stack pane is generally better when we're dealing with components that have different sizes. So if I want to put one component inside of another one, and the one inside is a smaller size of the one that surrounds it, then it makes sense to use a stack pane. Now, border pane, we don't see anything in a border pane. The reason for that. Now, a border pane works, you have borders. You have a top border, as you guys see with my mouse. You have a left border, a right border, a bottom border, and then you have something called the middle region. When you are using a border pane and you add visual components or nodes to your border pane, you have to actually specify where you want it. So do you want it at the top, middle, left, right, or bottom? So there's more work that needs to be done with the border pane. Since I did not specify any, you don't see any. Now for a grid pane works where it takes your pane, the grid pane, the thing you're attaching it to, and it makes a matrix out of it. So it divides into rows or columns. That's why it's called a grid. And as you can see, we're only seeing the 3rd button, and the reason we're only seeing the 3rd button, button 2 and button 1 are underneath this the 3rd button. With a grid pane, similar to a stack pane and a border pane, in order to move this guy around, you have to specify where you want it. So you need to specify which row, which column you want this to be placed in. If you don't do that, it'll just default it to the 0, 0. And since we didn't do that here, all the buttons went to the top left corner. Now, let me also say with a grid pane, I find to be one of the more powerful ones when it comes to creating complex UIs. So I think this is the one you want to become more comfortable with. Now, HBox or horizontal box it's like the first part of a flow pane. It's just going to lay out all your visual components in one row from left to right. Okay. A VBox is just the flip of that, where it lays all your visual components from top to bottom in one column. Okay. So these are your different panes you have here. Again, you can use a flow pane, HBox, and VBox. You can add components to them without having to worry about them not, you can add them and they should all show up. But if you were to do that with a stack pane, border pane, or grid pane, you would need additional constraints set in order for them to be displayed correctly. Let's look at the layout panes. So the layout panes, the way they work, this is just a repeat of what I've said. The stack pane, it places nodes on top of each other. Useful when we have nodes of different sizes. A flow pane will place nodes left to right, up and down, very similar to reading. A grid pane will place nodes in a 2D grid, but you need set constraints for your nodes. Every time you add something, you have to say where that node is located with the row column arrangement. But grid panes are very powerful and very flexible. A border pane, you place nodes in regions, and you need to set constraints, the top, bottom, left, or right, or the center. I think it's middle in JavaFX. With the H box, again, places nodes in a single row, and then a V box, it will place the nodes in a single column. Now, here's some best practices when it comes to layout panes. I find that you want to use multiple panes. You want to start with one root pane where all the other panes are attached, and then you add buttons or you create sub panes for each region, and then you add your visual components to those sub panes, and then you add those sub panes to your root pane. And then we can, depending upon the complexity of the UI, you can break up each region into a smaller region and repeat that same process. Now, what I typically do, I would typically use a border pane as my root and add things to my border pane that specifies the region. So here's an example. So I may make my border pane the root pane, and then on the left, I will say I'm going to create a separate pane and make him a V box, and I may want to create a side menu for that. In the center of the border pane, I may create a grid pane, and this is for my main area. I can have a top. In the top of the border pane, I can create an H box pane. So the H box pane is a sub pane, and I can use that for menu items, and then I can have a bottom for a flow pane. In the bottom region of the root pane, I can have a flow pane, and then that could be for buttons like your confirmation buttons, cancel, okay, quit, things of that nature. So again, this is when we're developing full-scale UIs, you want to approach it this manner. It's really difficult to use absolute positioning, but it's also difficult to just use one layout pane and try to put things relative to that layout pane. What you would do is create a root pane, and typically it's a border pane because you can put things left to right, top, bottom pretty easily. And then within each region, you will have its own separate sub root pane. And I'm going to show you an example. So this, I can't show this code in PowerPoint. It's a pretty lengthy code, but what I'm doing here, and I have a screenshot of this in the next slide, I just spent maybe a half an hour writing code to build JGrasp. Of course, we haven't talked about functionality, so you will not see any functionality. And I don't have everything in it. And let me just show you that. You guys can see what this looks like. So hopefully this looks good on your screen. But the big window is JGrasp. And I just have my code, and I ran it, and it says this pop-up is what I created in Java. So of course, I don't have these icons here just because time constraints. I don't have a lot of time to find these icons and load them and things of that nature. But what I do have these labels here, these menu items here. Now, I do have a file browser here. I'm not pointing to a particular directory. That's why you don't see any list of files. But this is there, just like it is here. I don't have all the tabs here, just for time constraints. The middle area is where my Java code will go. That's a text area. Then you guys can see I have a compile and a JGrasp messages. That's similar to these tabs here. Again, I didn't add all this just because of time constraints. But you can see this is the starting stages if I wanted to build JGrasp. The way I did this, I have a I have a border pane as my root pane, and then in the top I have I think it's a flow pane or H box that goes left to right, and I think over in this side I may have a V box, but I'm not entirely certain what I have here. But you guys go ahead and see the code, and you can see how I'm sectioning things off and how I have different regions. For each region, I have its own separate subpane, and I attach things to those subpanes. And another thing I would like for you guys to see with the code is the amount of code that it took just to get to this point was about 100 lines of code. Now, and if we did this in, we did all this code written in Start, this would become very, very cumbersome. What you will see, I continued using my policy of keeping methods less than 25 lines of code, and I have a lot of methods, and I just have some methods calling other methods. That way, things are easier to manage. I know I can find things quickly, and I'm not asking one method to do a whole lot of work. So I encourage you to look at that code, see how it works. If you want to download it and add more functionality to JGrass, be my guest. I think it'll be a good exercise to do. So yeah, I would definitely encourage you doing that. But this is, again, this is just the starting stages of building JGrass. And with 100 lines of code and maybe 20 or 30 minutes, I was able to get this far and and spend another half hour to an hour, and I could probably build more of what you guys see here in the real JGrass. But of course, we still haven't explored functionality yet. Callback. So when we press something, what happens when that button gets pressed or label gets pressed or things of that nature. We'll uncover that in 15. So when we do that, then I may return back to this and add more code to it. All right, so let's talk about displaying text in JavaFX. There's several ways of doing it, and this is really important because in most cases when you have a UI, you're going to want to show text. So you want to make sure you know the different ways of doing it. The first way is a label. With a label, I believe the default behavior is read-only, which means it cannot be edited by the user. And you just create a label object, you create a label object, new label, and then whatever you put inside the parentheses would be what gets displayed on the label. Text box and text area are similar. A text box is a single line of text. A text area is a multiple line area of text. They both are editable. That's their default behavior, and they both have empty or no R constructors, where it will just show a text field that's empty. You can also call a constructor that has text in it, and that will display the text message. Another way to do text on a UI is just the text class. And with a text class, you have to create a text object by putting the X position, the Y positioning, and then the text. So with the text, you're usually going to be using absolute positioning. So just make sure you know the difference between text compared to labels and text box and text area. Now, in most cases, you also would like to look at the font class so you can set font for your textual nodes. And the font class can be used for any of these text classes. Let's talk about images in JavaFX, because in addition to text, you're more likely to want to display images to the UI or to the user through your UI. The main way of doing it is to use it. It's a two-step process. You use the image class to create an image object. So similar to files, we create a file object that just points to the file, but then we need some type of reader or writer that actually allows us to read data from it or add data to it. In this particular case, so for images, we would have to create an image object, and then and definitely with images, you would definitely, when it comes to UIs in general, make sure you remember to use relative path, file path. We talked about that, I think, last chapter, or chapter 12. And then once we create an image object, we can then use the image view class to display the image in the UI. It's very important that we create an image view object, because this is what gets displayed to the UI, or on the UI. We have to attach the image view as a node to a pane, and then the pane gets attached to the scene gets attached to the stage, and then we're good to go. You cannot directly attach an image object to your pane. That will lead to a compile error. You have to do it through an image view. There's two ways of doing it. The first way is 2 lines where I create an image object first, and then I create an image view object just by passing in the image object. Or I can do this in 1 line of code where I just say image view object, create an image view object, and I pass in the image itself directly. So those are 2 ways of doing it. Both ways work, but just make sure you understand that it's the image view you need to attach to your pane so that you can actually see it in the UI.